Drone cinematography in space, a new frontier for filming astronauts. The era of static cameras and limited perspectives in space is drawing to a close. The future of filming astronauts lies with sophisticated, autonomous drones poised to revolutionize how we capture the human experience of space exploration. These free flyers are evolving from simple internal assistants to agile, intelligent cinematographers capable of documenting everything from intricate tasks inside the International Space Station to breathtaking spacewalks against the backdrop of Earth. For decades, our view of astronauts in space has been largely confined to fixed cameras within spacecraft or helmet cams during extravehicular activities, or EVAs. While functional, these perspectives often lack the dynamic and intimate quality of professional cinematography. Now, a new generation of drone technology is set to provide a third-person viewpoint, offering unprecedented opportunities for public engagement, scientific documentation, and mission oversight. The current state: assistance with a lens. The groundwork for space-based drone cinematography has already been laid. Inside the ISS, NASA's Astro B and the Japan Aerospace Exploration Agency's INT-BAL are pioneering the use of autonomous free flyers. These drones, propelled by fans or small thrusters, can navigate the microgravity environment to assist astronauts with tasks and, crucially, document their work. Equipped with high-definition cameras, they can be controlled remotely from the ground, freeing up valuable astronaut time that would otherwise be spent on photography and videography. These internal drones serve as a crucial testbed for the guidance, navigation, and control systems essential for more complex external cinematography. The next leap: taking the camera outside. The true revolution in space cinematography will happen outside the spacecraft. Future concepts envision autonomous drones working alongside astronauts during EVAs, capturing stunning visuals that are currently impossible to achieve. These external drones will need to overcome a host of technical challenges unique to the harsh environment of space. A key hurdle is propulsion in a vacuum. Unlike their terrestrial counterparts that use rotors to push against the air, space drones will rely on cold gas thrusters or reaction wheels. Cold gas thrusters provide quick, powerful bursts of movement, ideal for rapid repositioning, but can introduce vibrations and potential contamination of sensitive spacecraft surfaces. Reaction wheels, which control attitude by spinning internal flywheels, offer a much smoother and more precise method for achieving cinematic camera movements like slow pans and tracking shots, crucial for high-quality filmmaking. However, they are less effective for large translational movements. The choice of propulsion system will directly impact the types of shots a space-based cinematographer can achieve. Another significant challenge is the constant bombardment of cosmic radiation. This radiation can wreak havoc on camera sensors, causing hot pixels, noise, and other artifacts that degrade image quality. To counter this, future space cinematography drones will require radiation-hardened cameras and advanced image processing software to ensure the delivery of pristine, cinematic quality footage. Finally, ensuring the safety of both the astronauts and the spacecraft is paramount. Drones operating in close proximity to astronauts during an EVA must have robust autonomous navigation systems to avoid collisions. Mitigating the impact of thruster plumes, which can exert force and contaminate surfaces, is also a critical consideration in the design and operation of these external platforms. The future of space filmmaking. Overcoming these challenges will usher in a new era of space cinematography. Imagine a drone autonomously tracking an astronaut as they work on the exterior of a spacecraft, executing a graceful orbital shot that reveals the vastness of space behind them. Picture a drone providing a close-up, over-the-shoulder view of a critical repair, offering engineers on the ground an unparalleled understanding of the situation. This technology will not only provide more engaging and awe-inspiring footage for the public, but will also serve vital scientific and operational purposes. Detailed, high-resolution video from multiple angles can be invaluable for mission analysis, training future astronauts, and troubleshooting problems in real time. The development of drone cinematography in space represents a convergence of robotics, artificial intelligence, and filmmaking. As these technologies continue to advance, the way we see and experience space exploration is set to become more dynamic, more immersive, and more inspiring than ever before.